is a bit of an interactive session, so you can't be too quiet. I'm going to need to hear from you. It's a little bit hard for me to see the chat window, but doable. So ready? Let's delve into this. As the title says, as a data scientist, at some point you need to become an ML engineer. And as a machine learning engineer, at some point you need to have some data science methodologies, acumen in mind. It's really interesting to see how these two disciplines are so related. All right, here's our agenda. We're going to talk about the case of the missing bullet holes. Now, this is a data science story before it was even called data science. And then, if I say AI, you're going to say, more on that later. I want to make a distinction between deterministic systems versus probabilistic systems. And then, what is so confusing about the confusion metrics? It's interesting to see how we move from brute statistics into calculus 2. As you go from one algorithm, probably structured data, onto pictures and images, you need to have a different approach. And all of that really is captured by the confusion metrics, really. That is the language of models. And I believe we will have time. I want to demo for you building a model. Our machine's going to replace me. This is a wonderful topic I want to spend a few minutes on. And of course, I want to demo auto AI for you. I might do the demo before this topic. We'll see how the time goes as we progress forward. So, Abraham Wald and the missing bullet holes. I want you to imagine World War II. This goes back, 1940s, early 1940s. And the Allied airplanes were coming back, landing in England, riddled with bullets after the battles that they did in the air. Back then the airplanes, you could open the roof. It was convertible planes. So they said, this is ridiculous. We have to reinforce these airplanes. We have to put metal shields all over the place because look what's happening. So they got Abraham Wald. He was a famous statistician. Oh gosh, tender age of 48. He spent some years at Columbia University, and they said, look, Abraham, come in here, and here he is. Tell us, what do we do? So Abraham went to the field, like any data scientist would do. At that time, it wasn't even called data scientist. And he started gathering data. See, he's counting the bullet holes on the airplane. After 2 days of doing all of this activity, he goes back to the powers to be, the generals and so forth, and says, I know where you can reinforce the airplane. They're like, really? Do you? Yep, I do. Reinforce the airplane in all the places that do not have bullet holes. That do not have bullet holes. After all, they made it back. It's the ones with bullet holes elsewhere that didn't even get a chance. This is today's best AI systems because Abraham wanted today, although world knowledge. He had experience, not just training. Based on that. Very well. Let's move forward. I want to take a look at the chat. I can see it here. Lagging, you say? Is it still lagging? What is lagging? Like the
audio and video was cutting off sometimes, and it was a bit hard to hear you earlier.
Oh, well, did that change or is it still the same? Should I say?
It seems fine now. but I don't think all of us heard like after the part where you said that they should reinforce the parts with no bullet holes.
Okay. All right. So fine. I think you guys did get the message in here. The idea was that this sort of, remember, machines predict, humans judge. We are the final arbitrators. The decision, for now anyway, is made by the human. Thank you very much for telling me it's going to rain tomorrow. I'll be the judge if I want to go and do this and that or not. And Abraham Wald, in here, all he did was count the bullet holes. But the prediction, the judgment that he made that let's reinforce the airplane in all the places that do not have bullet holes is something that is elusive from the AI, best of AI systems even today. So we have to do this together, ladies and gentlemen. And I can't move forward until I hear from you. So I think I'll try to see the chat also. I'm going to say bzzzt, and I want you to say bzzzt immediately, in a picosecond. The first thing that comes to your mind, don't think about it. Are you ready? Are you ready? So if I say sky, what's the first thing that comes to your mind?
Ooh.
I love hearing voices. Yes, it is. And some people actually say clouds, so I had to put that in there. All right, we're going forward. Ready? If I say grass, what would you say?
Green.
One person say cut. So I have to put a lawnmower here next time. Now I'm going to have to help you a little bit more with the next ones. If I say AI, I encourage you to say, give me a check.
Neural networks.
Data.
What else? Data comes later.
Sentience. Machine learning.
Machine learning. You know, I was watching Bloomberg a while back, and they had the chief operating officer chief science officer at Google there. And he said, over at Google, you know, we don't use the word AI all that much. You know, it has lost its gravitas, its meaning all of a sudden. AI. You know, there's a bird that wakes me up every morning. It's like, machine learning makes more sense. It's about building patterns. I usually encourage my students when they get into these conversations with the heavy hitters to use machine learning more prevalently than AI. It goes a level deeper. So I'm going to have to help you with the next one. If I say machine learning, give me a couple of thoughts. What would be the next thing you might say?
Neural networks.
Models.
Reinforcement.
Well, remember, humans judge. What do machines do?
Predict.
Bravo. This is all about prediction. Yeah. You could say predict and classify, but classification or prediction. This is what this whole technology is about, to predict. When we translate from English to German, that's a prediction. It bubbles up a bunch of passages. It picks the one that has the highest confidence value. That is what you're trying to say from English to German translation. That's a prediction. Now, it gets harder here. I think I'll have to jump in. There are three ways to predict: supervised learning, unsupervised learning, reinforcement learning. I want to talk about these later on. Some algorithms that go with supervised learning: regression, classification, naive Bayes, k-nearest neighbor. Naive Bayes is really cool. It's, if you like philosophy, you would love naive Bayes, the Bayesian theorem, but a priori, your beliefs change over time. Unsupervised learning has these k-means. Clustering is the one we use most with unsupervised learning. You know, with unsupervised learning, you don't give it a name. but you have to have a lot of data. So the machine looks at all these data and says, I don't know what they are. I'm going to put them together in a basket up here. Looks at another picture set of data. It's all pixels, vector graphics. I don't know what they are, but they kind of look the same and different from that group. You and I know that's an alligator. This is a crocodile. So it's the matter of clustering, but we never typed anywhere alligator, crocodile. In supervised learning, you do. You type in Armen, you type in Kilimanjaro, so it gets to know what those things are. And with supervised learning, you don't need that much data because you helped it. You gave it the answers. Reinforcement learning, my dears, we need to get together again in the future to have a conversation about that. But suffice it to say, reinforcement learning really doesn't go through training. It learns on the fly. You know, there's an agent that constantly is checking the environment. It's giving a thumbs up or a thumbs down. Do this, do that. No, yes, no, 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 yes. The self-driving cars, they use reinforcement learning. So, my dear, the next one, I think you can help me. Are you ready for this one? And what is algorithm's favorite food?
Variables.
Data.
Data.
Loves to eat data. Let's talk a little bit about data. So, you know this. You can probably teach me this one. There are two types. There's categorical, looks like that, or qualitative. And there is quantitative or numerical, looks like that. All right. You know, at the end of this, I want to ask you a question. I want to give you a scenario and see if you can put it in one of these categories for me, one of these breakdowns. Back to the categorical, we have nominal and we have ordinal. Nominal, there's no order, male, female, frequency, proportion, pie chart, bar chart, good way to describe this. Ordinal, same thing, except it has an order. Are you noticing something, ladies and gentlemen? There's a gap. Do you see this gap between the bars, the space? Bear that in mind. Now, let's go down here, quantitative, discrete, and continuous. Discrete has separate indivisible values, number of rooms, 4 rooms. Let's see. You're noticing there's no space between them, aren't you? And then continuous, this is the typical parabolic first interval, those sorts. Now, I have a scenario, and tell me which one, not this deep, just up here, or whether I should put it in this qualitative or quantitative category. Let's say you're a campaign manager for somebody who's running for office around here. And you have an ability to look at the Twitter, Instagram, and all these chat scenarios, and you have detected a negative sentiment. The AI has detected a negative sentiment about what people are saying. So this is important. The model that you have needs to be deployed constantly. That's how Telegram, Twitter, all these things are happening quickly. Can't do every 10 hours. So you have to go back to your candidate and say, I don't know what you said in your speech last night, but at this rate, I don't think you're going to be elected. You have to go and fix this. Where should I put that story? Does it belong down here or does it belong up here? That's sort of a data that I scoured.
Categorical?
Categorical.
You have 2 categories, positive and negative, the sentiment. So I think it's categorical.
You are absolutely right. You know, it's unstructured data, for one thing. It's tweets, it's language. It's not something that came from a CSV file. It's not something Excel. This down here, the quantitative or numerical, is Microsoft SQL Server, Oracle, IBM DB2, Baidu, Tencent, That's where it comes from, a database. But this are pictures. This is stuff that's on our phone. This is tweets, PDFs. These are much harder problems to address. But you judge based on the number of negative tweets? No, it's interesting. The NLP doesn't really look at the tweet as a positive or a negative thing in its own. NLP goes through a process and it gives it a confidence value. But first, some years ago in our office, we hired a whole bunch of people with a PhD in linguistics. They knew nothing about AI, programming computers. They knew grammar. They knew English really well. We brought them in. We showed them little snippets, passages, short sentences, and they started to classify these. 5 classifications. We, as humans, ocean, openness, conscientious, extroversion, agreeableness, neuroticism. Not like clinical neuroticism, but happy, joy, sad. All of us fall into those 5 categories. So now when the machine sees a new sentence, for example, has a separate indivisible values, it tries to see what is the sentiment of this and tries to put it in one of those buckets with a confidence value. Perhaps the confidence value for the sentiment of this is 0. It's not up to +1, -1, that's happy, joy, and this one is sad. So that's how it reckons that a sentiment has gone negative, or any sentence. See, this is the structured data. There's not much growth expected in this. The big money, the big science, the big technology is in the data scientist and machine engineer, machine learning that is working with images, with unstructured data. They have to take measurements, temperatures. They have to go outside, not just sit here in the office and check, do a SQL call and work on the Excel spreadsheet. And so the proliferation of the science is really taking place in here. Now look at this, the amount of data that's being gathered. When I see these pictures down here, the first thing that I think about is how important 5G networks are. The other thing that I think about is how important is edge computing, not cloud computing, edge computing. The algorithm might be trained in our Dallas servers, or Google has it Google's servers are in Lake Michigan, built in the lake. That's a nice way to keep it cool. I don't know why we put ours in Dallas. Where's the hottest place in America? Dallas. Let's go pick one there. But the algorithm now needs to the automobile. You've seen how people are walking nowadays, right? They walk like this. They're looking on their phone and they're walking. I see them constantly. I'm like, lift your head. Is it rainy, cloudy? See what the weather is. And you see how people are driving now, right? They drive with texting and drive. I see on the highway they're slowing down. It's not because they're careful driver, because they got a text. All of and people who are walking with their dog, the leash is like, 3 meters in front of them, texting. The automobile sees it. It has Brembo brakes, the best brakes. It can stop faster than the human, but one of those 2 entities is going to be taken out. It's physics. Or go crash into another car if you want to save those 2. But the primary thing is to keep the driver safe. Who do I take out, the dog or the person? Sometimes it should be the person. That decision must be made at the bumper of the automobile. I don't have time to send it all the way to Dallas and come back and make a decision. So edge computing, 5G networks becomes really important as we move forward in an AI-enabled realm. Look, this is actually right from your book. The areas that AI is really going to be helpful. And as you bring this to the really the mindset of the UAE practitioners in government, cybersecurity is huge. And a lot of AI is being used in here, machine learning, to predict when, what, how will the next attack be. Finance, quants. All of a sudden, these UBS and Bank of America, all of a sudden they're finding out that there's these young kids coming in here wearing their Hawaiian shirt and loafers, and everyone else is in a suit and tie and working, and they're getting the biggest salaries. They come whenever they please and leave when they please. But what they're working with is not just they're taking into account what's happening with inflation, the macro and the micro economics of this. How is that affecting interest rates? How will that then affect my bonds and equities and so forth? How can I advise my clients better during times like this? Maybe buying stocks is not the way to go. Agriculture, they talk about the green gas effects and how that's impacting global warming. You don't necessarily need an automobile with the exhaust pipes putting out all that smoke. Farming puts out a lot of methane. It is a cause of global warming. If you go to the Arctic or Antarctic, there are a lot of geysers there. Little methane is coming out. It's undetected, can't smell it. But if you take a match and just hold it next to that hole in the ground, a little flame opens up. This is methane that's coming out. We didn't do it. It's not a human thing. That's causing global warming. It's really interesting to make those predictions. The fires, the monsoons in India, it's energy, healthcare. Notice how healthcare is becoming personalized. That's the whole idea. It's one pill does not fit all. There are interactions between these pills. Education is becoming personalized. And science. I love this part. I have one slide for you that talks about how quantum computing and AI are coming together. Predictive modeling, theorem proving, deductive reasoning, experiment planning. The language of quantum is linear algebra. If you get the chance to study linear algebra, it's about vectors, because it's about the spin of the electron. You have a step forward into understanding quantum mechanics. And chatbots and so forth, fantastic business solutions. So, about cognitive systems, the probabilistic type. Well, my dears, we have a deterministic systems. The computer in front of me and the one in front of you is a deterministic system. It does what we say to do or it doesn't. Yes or no, true or false. I put a command in there and either it will give me an answer that I'm expecting or it says something crazy like null exception thrown. I think we did away with that error message finally. And then I go find out where I missed my semicolon, I didn't close a bracket or something, and the code works. No, not probabilistic systems. There is no yes or no in here. It's all based on confidence value. In fact, I'm starting to sound like this guy over here now. You study AI as much as I have, you're starting to sound like this guy. My family members, they say, my wife says, Armen, would you bring the dry cleaners home on the way when you're coming home? I am 89.4% confident that I would bring it. It's like, I can't even talk to this guy anymore. Will you bring it or not? Well, there's a chance I might forget. Did I give you an example of a deterministic system? Nice. So there's, force equals mass times acceleration, this. And we have meters per second square and Newton over here. So if I, egg, right? If I drop an egg from here versus from up there, big difference. And I have a constant 1 kilogram. So I drop an egg from 1 meter per second, I can tell you it gives me 1 Newton. 2 meters per second square. I don't have to go to find out what 10 meters per second square would do. I can tell you with full determination that 10 meters per second square is going to give me 10 newtons. Everything fits perfectly on this line. Not how Watson works, not how Siri works, Alexa, no, this is not it. This is how my computer works right in front of me and the one in front of you. Now, let me tell you a story about probabilistic systems. Regression. Regression is a tricky word. Regression, it kind of makes you feel like regress, go back. Well, yeah, it is. We go back to see what happened in the past, so we don't make the same mistakes in the future. No, so we can make a better prediction for the future. It's a regression. Here's linear regression. Okay, I'm going to put salaries against education. There's how much money you can make. High school, bachelor's, master's, not bad, not bad, not bad. Doctor, PhDs, oh yes, yes, yes. Of course, we cannot forget our new graduates. This one went way up there behind that screen. So, okay, well, so what do I do? I need a line. I need a line that's a really good fit. How about that one? Now you might argue, I mean, this is not a really good fit. Maybe it should be a little bit lower. Maybe it should be slanted. I want to talk about that. There are mechanisms that we move. This is the whole idea. Best fit. You know, this line has to be fair to this data point, to this data point, to that one, and the one that's right behind here. Well, not how Watson works. At least it's a probabilistic system. Oh, logistical regression. Now we're talking. So, yes or no, true, false, 0, 1. The story in here is the people are leaving this company. I don't know, it's a wonderful company, but there's just attrition going on. Not the great resignation, everything is fantastic, distance from home. Come to find out that if you live really far from the office, odds are you might be the one that's going to say, I can't do this drive anymore. So there we go. These people that seem to be close to the office, 10-minute walk, 5-minute drive, hey, life is great. And then there are those that actually do have a 1-hour drive and they're like, I don't mind it. I like to sit in the car. It's my only me time. I just focus, listen to a pod, and I'm okay with that. And then there's a bunch of people that are just, I can't do this commute. It's killing me. And of course, one other guy in here who has a short 5-minute commute, but I got an amazing job at Microsoft is going to go. So how do I connect these two? Well, that's the S-curve. And there's the probability. Nice. You see, the S-curve is everywhere. These algorithms use the S-curve. It's dichotomous, it's bimodal. Learning is a function of experience. Did you know the moment you woke up, you were mired in the S-curve today? I know it's afternoon over there. When you make popcorn, pop, 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 saturation. When you start to run, and then lactic acid builds up, saturation. When I used to travel, there was this thing called the travel some time ago. We did a lot of it. I used to have the top room in the Hiltons. Now I'm next to the boiler down in the basement, but that's different. I would go in and I'll turn on the shower. Nice. Go inside the shower. It gets cold all of a sudden. Blame it on the S-curve. Ernest Hemingway. You guys read Ernest Hemingway, right? Of course. In his book, The Sun Also Rises, they asked Mike Campbell, one of the people in there, how did you go bankrupt? He said, slowly at first and then suddenly. This is what really also happens in a sense in the neuron. We always have think of my hand as this is an axon. These are dendrites. And the tip of my fingers are the synaptic junctions that connects to this other neuron. There's always a potassium ion channel that's open in here, but it's not strong enough to wake this one up. After a while, when you do the same things, a pattern is built, habit is formed, addictions then come on. That's another story. So a pattern, just when the water goes down a funky way down your backyard, after a while of raining, you notice it has created its own sort of a river after a monsoon season or something. It goes that way. And it is so it becomes a electron. It's a signal, it's either it's on or it's off. It's just electricity hydrons in the nervous system, chlorine and potassium. I have this. If there's anything that you want to remember from this talk, ladies and gentlemen, let it be this slide. Machine learning is optimization. Do you see this here? This is a hill. It's a hill. And my friends, they get me together. They say, Armen, yes, I want you to climb this hill. Oh, okay, I can do that. It's easy. No. 2 conditions. Oh, really? Mm-hmm. You have to do this blindfolded. Where's my Jamaican bandana? Ah, there it is. And you have to get to the top in as minimum steps as possible. Ah, really? Okay, I can do this. So amongst friends, it's all safe and sound. When I start my walk, I notice that the slope, so slope is very important. Slope is learning rate. The slope is really steep. So I'm taking really big steps. These big steps are akin to the weights on a neuron. When they say hyperparameter optimization, it's about this. But I don't know what's happening with the slope here, because I'm taking these giant steps. They told me I have to get there in as minimum steps as possible. All of a sudden, boom, I go past it, not optimized. I go back propagation, forward feed, back propagation. I'm like, okay, that didn't work. I'm going to take much smaller steps. Where is my Picasso? Insert a draw. So I come back and I'm like, okay, that was horrible. I'm going to take smaller steps to get there. That's me taking small steps. It takes me 5 weeks to get here. And by the way, you never get to the very top. So there's maybe 1 centimeter to this side or to that side. It's a probabilistic system. If I didn't have this blindfold, I could see that the slope is changing. Right? Over here, it's it's tangent of my x and y axis of my function. I'll just put it in parentheses. The tangent is equal to 0. So the machine knows that it has reached a plateau. Either it's going to go down or it's going to go up. Because data really looks like this. The data looks like this. Either I go up or I go down. But if I do this many times, forward and backward, I'm going to start with a very big step, because I can tell after doing this a long time that the slope in here, I have a measurement calculation of the slope. It's not the same. So over here, I will change my step. I will make even a smaller step, hyperparameter optimization, adjustments. That's what they do. And it would really help if I had the entire area knew this, because in reality, it's 3-dimensional. It's not just up and down. And then there's this notion of global and the local minima, maxima. We'll talk about that in a bit. So that, my dears, is what machine learning, when they say machine learning is blind, it's truly true. Machine learning is blind. Back to our regularly scheduled programming. Slideshow from current slide. So this, my dears, is the simplest, straightforward. This is a machine learning algorithm, method of least squares. You don't need convolutional neural networks, generative adversarial networks. But there you go. This is machine learning right there. The trick is to find out how can I put this line in here that would be the best depiction, the best depiction. So we have error. This is all errors in here. This is an error I need to fix. That's an error I need to fix. And I need this line to really do justice to everything. So y, I know what y is. Y hat is over here. This is y hat. I don't know what that is. So how do we calculate slope? Y2, if this is, for example, y1 and y2 minus y1 divided by x2 minus x1, right? This is how you calculate the slope. This is, in fact, how you calculate derivatives. And those are, that's how you calculate a slope. All right. So this is what's going to give me my slope. And, of course, mx plus b, that's an x, is what is going to give me my y hat, or this point should be here. This point should be here. B is my intercept. This is B. X is 0. And whatever happens to hit the y-axis, we call it B. 0, comma B. So if I can find out where my intercept is, it could be down here, it could be 0. And if I can find out what my slope is, m is the slope, then I have found out what this is. Because the trick is, let me do another Picasso for you. Background, so we can see now. Give me just nice. The new slide is too much. It's fine. Be that way. See, let's say we have a whole bunch of data points, right? This is a typical study that you did: travel, distance traveled, speed gone, and whatnot. And we have and for this, I want to do insert a line. Aha. Now you might come and say, Armen, I think this is going to be better if you did it like that. See, I just changed the angle of it. Another one would come and say, no, Armen, I think that's good, but you also have to kind of move the whole thing. So, my dears, we learned two things. Changing the slope of this is the whole idea, the whole game is to make this the best fit, is when you change the weights, the hyperparameters. See, the weights are on the synapse. The weights are on the synapse. When I move the entire thing, that's when I am actually changing a thing that happens in the bias, the S-curve. So that S-curve is what happens in the nodes. They used to call these neurons, but that does injustice to what God has created. So these are nodes. And the bias takes place in here. The bias is what makes this go up and down. And what happens on the synapse, the weights are adhered in here, is what causes this to change its angle. But the thing is, it's not the human that tells the machine. It is the machine that finds it out, hence the intelligence, by doing this over and over and over again. Very, very fascinating, very fascinating. Back to our regularly scheduled programming. So there we go. This is how I think this is a single perceptron. This is multi-perceptron. So they're both neural networks. This one is deep learning. This one is not deep, only because it has more layers. I think Microsoft has the record with their visual recognition, 154 layers. Each one there's a different job of bias, trying to make it better. There are many different ways. We don't just, the S-curve, draw, maybe back to my Picasso. The S-curve, you guys are familiar with the S-curve. That's the sigmoid operation, right? 1 over 1 plus e to the minus x, exponential growth, minus x. That's one thing that happens. The next layer says, I'm going to try a different one. I'm going to try ReLU. You've heard of rectifiable linear unit, ReLU. That's another bias. The job of these things is to move the whole curve. The ReLU is kind of like this. It comes in the middle and then linear, straight line, linear unit. There's another one. This is the one that is used most often, and it might be used maybe over here, parabolic tangent. These, do you see how interesting it is? You start to move away from statistics, inferential statistics, logistical regression, into calculus 2. You have to calculate the area under this entire curve. That's an integral. Remember the area integral. You have to calculate the slope each time as it goes up. Tangent is 0. Now what? I'm going down, I'm going down. This is a mathematical trap because there is a lower point. I want to get down to the floor here. When you make your bed, you get the sheets, you go like this, freeze frame. The sheets are like this. The point on the sheets that is about to touch the mattress, that's where you want to go. So the machine is always looking to go downwards. There's a famous formula called DJ dW. W is the weight. We put a weight of 2 on this, right? So my input might have been, I don't know, 5, so it's all good. 5 times 2. 5 times 2, 10. Now, the job of the node is to collect 5 times 2. Maybe this one was 3. This little one over here was 3. They collect. The J is the activity that's going on, more on that. And of course, you do partial derivatives because you want to keep one of them constant and just change the other one. As long as this division is a minus, machine, go that way. If the division is a plus, don't waste your time, machine. So the machine is doing calculations on the slope. It's going upward, boring, doesn't even do the calculation, flies through it. Tangent 0. Ooh, I'm going down. So DJ dW is now minus. Yes, gets down here and says, hurrah, I have a new number. This number, instead of 2, maybe it should be 2.1. Tangent of 0. But then after a while, it goes up, waste of time. And then it says, oh, I didn't see this one. Wow, this is really deep. Look, I have a new number. So it says, this must be my global minima, maximal minima. And maybe it wasn't 2.1 after all. It should have been 1.96. 5 times 1.96. So when I adjust this, in a sense, when I adjust this 1.96 and 2. See, I didn't do it. The machine did it. It just looked for a downhill approach to get to the minimum until it found the lowest point. It says, all right, now I have a better adjusted hyperparameter. Now I have a better angle for this one. Thank you very much. It does that. Slideshow, play from current slide. How are we doing with time? Boy. Now, we talked about machine learning. The overarching discipline, you could say, is artificial intelligence. Machine learning is part of it. Deep learning now, ladies and gentlemen, is not such a big hurrah. The big hurrah nowadays is actually foundational AI, transformers. We're working on that. Everyone is working on that. This is as you try to move from to artificial general intelligence. In our laboratories in two places, in Almaden research laboratories and the one in Zurich, the researchers are working on giving the machine common sense. The machine now has a foundational AI. It knows a thing or two about this and that. Now I can take this foundation and make a doctor out of it, a lawyer, suicide prevention, police, hotel concierge, and so forth and so on. But it's essential now for me to have that. Let me take a look at the chats. Seems to be anything interesting. J, DJDW. J, we need more time. I could have gone through the formula. J is really, it's the activity. It's the 5 times 2. That's for example, and more. We need more time to that. But suffice it to say, activity divided by the weight. As long as that answer is minus, go that way. Oh, this is interesting because I want to put this in the context of quantum machines. So I'm going to skip the reinforcement learning for now. Let's talk about supervised learning. You can have classification. Looks like this. Crocodiles, alligators. Identity fraud detection comes from here. Image classification, customer retention, diagnostics, and then you have regression. From there, you can do weather forecasting, market forecasting, estimating life expectancies, advertising popularity. Supervised learning, you have to give it the what it is. You have to type, this is a cat. That's a Nimbus cloud. This is Armen. Unsupervised training, it's clusters then. There's a clustering job. Dimension reductionality, big data visualization. Structure. So as you can imagine, each one of this is a quantum algorithm designed to do this one job. Clustering is the other thing it does. Recommender systems. This Amazon recommender system is a huge thing. It doesn't know, I buy a book, it doesn't know what I like about my preference in books, but it gives me a recommendation in the bottom that other people who bought this book also bought these other books. And I look down there, I'm like, that looks really interesting. So I end up getting the recommended book when I actually do that. So it's really interesting to see the difference between these two. Unsupervised, you need a lot of data. Supervised, you don't need that much data, but it is arduous because you have to type what that point, that picture, that sentiment is. Negative sentence, sad, happy, so forth. Brute statistics versus artificial neural networks. Remember, we did the logistical regression. That was good. Support vector machines, random forest, Bayesian inferences. That's their job. So that's what they do. Neural networks goes deeper, though. Neural networks goes into the derivatives and the integrals. It's funny, you go from statistics to calculus. My dean in my university says, Armen, you want computer science people in your class, right? I said, no. I don't want computer science people. I want it from the architectural school. I want them from the nursing school. I want them from a manufacturing school. But it helps if they had statistics. I teach a senior level, so by the time they get to the last year, it helps if they had statistics and math. That to me is more valuable than who knows how to do excellent Python coder. Regression takes the data and tries to find the results that minimize prediction mistakes, maximizing what is called goodness of fit. Remember that line? We want a good fit. Have you guys heard this joke? You haven't. A physicist, engineer, and a statistician, they go on a hunting trip. It's great. Well, around here, I'm in Massachusetts, in Boston. We don't do guns and stuff. We hunt with our bows and arrows. Yeah, that's it. So the physicist goes, I got this. They see a deer in the woods out there. I got this. So it does the calculations of the curvature of the earth, the speed of the arrow, the resistance of the band, and goes, misses the deer by 5 meters to the left. The engineer comes and says, no, man, you got to take into account the wind. You know, that's a big thing. There's one of these. Where's the wind blowing? I got this. Misses it by 5 meters to the right. The statistician doesn't even bother pick up the bow and arrow. He goes, hurrah, we got it. Used to be a funny joke. Being precisely perfect on average can mean being actually wrong each time. Regression can keep missing several feet to the left and the right. Even if it averages out to be the correct answer, it means it's never really actually hitting the target. Now, unlike regression, machine learning, they may be wrong on average, but when they miss, they don't miss by that much. Statisticians describe this allowing some bias in exchange for reducing variance. See, inventing a new machine learning method involves proving it works in practice. You, as a data scientist who is working with unstructured data, I have to wear my jacket, get my hat, feel the heat. Nowadays, it's the heat. The whole world is like warming up super. The sweat under the sun, take measurements, this and that, and come back and see what I can do with these measures. In contrast, inventing a regression method, so that data scientist is the one who sits in this office, doesn't have to go anywhere. With just a SQL call into Microsoft SQL Server, get a CSV file and do some analysis on the CSV file. Oh, I'll sit it nicely in here, drinking coffee, finish it and go home. So it's really interesting to note the differences. Machine learning has less need to specify in advance what goes in the model and can accommodate the equivalent of much more complex models with many more interactions between the variables. And I stole this saying from this amazing book, Prediction Machines. I have to show it to you. Do you see? Amazing, amazing book, amazing book. This is a mandatory reading for my class. So, Denny, I don't know how we're doing with time, but I'm just going. So what is so confusing about the confusion metrics? This is what's going to lead me to the demo. So how important is accuracy? And we're talking about models. We're moving into models. So your client is going to come to you and say, how do I get the most accurate model? Well, as a data scientist, you know what data scientists do. They answer with a question. What business challenge are you trying to solve using the model? Oh. Well, because accuracy may not be the one and only thing we want. What about precision? What about recall? Maybe these are more important to me than accuracy is. Look, this is my fishing net. Red fish, relevant data points. Blue fish, noise. So my search engine goes out there, gets some gut stuff, and 3 of them are spot on. 1, 2, 3. Should have been 5.6. So that's my recall. The precision, on the other hand, is 3 of them are spot on, and I happen to have a total of 4 data points in my net. So my precision is 0.75. Another scenario. Oh, look at this. Every single relevant data was found by my search engine, but there's too much noise in here. I have to sift through a lot of unnecessary data. So we have to work on increasing the precision of this machine. Oh, what about this one? Wow, perfect, no noise. I got what I wanted, but look how much important data I am missing. 0 false positives, 100% precision. There's no blue fish in there, but there are many false negatives. There are many false negatives. See this? Actually, accuracy would be, let me do my Picasso. Accuracy in here, to calculate accuracy, you get the true positive, that's good. And you get the true negative, that's good. I told you you had COVID and you do have COVID. Okay, at least I know. I told you you don't have COVID and you don't have COVID. So that's good too. But these are the ones that are problematic, false negatives. You know, you didn't have COVID, the test shows you have COVID, now you have to go quarantine for 2 weeks for no reason. This one's probably just as bad. False positive. Nah, you're fine. But all this time you did have COVID. The test didn't pick it up. So to calculate accuracy, whatever, just do it. So we have true positive, the good one, the benign, plus true negative, divided by all of them. All of these. I'm not going to type all of them. All. Add all of this. That is the how. So it's very important as we move forward. Play from our current slide. As we move forward, I am going to show you, this is a screenshot from the lab that I did. And notice, receivable operating characteristic. This is the lingo, this is the language. When you go to our data science floor on the 3rd floor in Cambridge, everyone's talking about methodology, the method. You go into the AI floor, the other one, everyone's talking about pipelines and the confusion metrics and accuracy, recall. So true positive rate divided by the false positive rate. True positive rate divided by the false positive rate. That's what I want to know. Before I go here, I want to take a minute and show you that in action. Stay with me, stay with me. Where did I put my browser? Might have been behind. It was right here. Nice. There we go. This is IBM Cloud, ladies and gentlemen. If I was working in Microsoft, the name of this would be Azure. In Amazon, they call this AWS. Google calls it Google Cloud. IBM calls it IBM Cloud. So it's interesting. In the 20 years I've been in this company, I've seen what I call the demise of the products and the rise of the API. When they say the API economy, all of a sudden we have become Lego builders. You know, the days of installing $14 million thing is finished. A bunch of, IBMers in the blue suits in a blue LTD would go to a blue building, and we would put the database in the basement, the application server in the middle, and the WebLogic, for example, and the WebSphere, and the app itself on the top. Those 3-tier architecture is finished. Now it's pay as you go, 20 cents a call. You click, it's 20 cents. So we have to now become Lego builders and put all these APIs together to make a solution. The catalog, I call the catalog the Mall of Dubai. I was there. I was staying at the Kempinski Hotel. You can go ski right next to it. You can buy everything in the Mall of Dubai. So that's what the catalog is. Look how many good stuff there is. I don't know too much about these guys over here, a little bit about blockchain, yeah. But these are my children. They live here. I got 19 of them. Watson Assistant, one day we should get together and build a nice chatbot. Watson Studio is where I'm going to go. This is really an IDE, integrated development environment. It's more than just an API. It's like the table. See what the table you're sitting at right now? That's Watson Studio. On your table, you have visual recognition, you have knowledge studio. All these things are the Watson Studio can bring them together. Language translator, machine learning we have to use, speech to text, NLU. These are all just open scale. It calculates how fair is your model. Fairness and biases is a huge undertaking now. All right, let me go, and because I have created these, so no sense starting from scratch. I'll go to my dashboard where after many years, you end up getting these big numbers. I'm going to find my Watson Studio in here. And I'm going to bring in a data set, and we're going to build a model. Speech to text, tone analyzer, assistant, discovery, Watson Studio. I was working with Anam a few while back. That's a good one. Let's bring this up. If you see blue, ladies and gentlemen, click it. Can I show you the data we're going to bring in? I will let this guy do its thinking here. There is my German credit report, open with Excel. This is an open source data set made for Kaggle competitions. I know. Open with. Thank you. I have to thank the machine each time it does something. Thank you. So, this actually was built in 1982 in Germany, and it's being used in training features all over the place. Kaggle competitions, that's a Google thing. They use this to demo all sorts of things. How many rows? Command, 5,000 rows. See that? 5,000 rows. And so this is the credit. The bank wants to give a loan to somebody. And there is a risk that that person may not give the loan back. As a bank, I would like to know which one of the, is it the duration? Is it how much money they have in their savings account? Maybe it's the loan amount. What are, I'm not after people. I'm not going to go grab people. I just want to find out the behavior that might lead to a fraudulent activity. Let's say this was 2015. Right? It's UBS Bank. It's giving loans to people. And notice this column. This, my dears, is supervised learning. I gave the answers. It's like when your students, they're studying for the exam, you study the questions at the end of the chapter. The answer is in the appendix. You go check the appendix, see if you got it right. And then when they come to take the test, you as professor, you would give them a different, but they could infer, draw from what it's not going to be the same question. That would be overfitting. Of course, they'll get it right. So we found out that the person who works at UBS knows that these people were no risk and they were risk. So I gave the answer to the machine. I said, machine, study this. So the machine says, this is how I'm going to do this. You got 5,000 rows? I said, yes, I have 5,000 rows. Machine says, I'm going to divide this into 3 chunks. 3 chunks. First, I'm going to study the first 2 chunks, memorize what patterns there are, and then I'm going to close my eyes and see if I can answer the 3rd chunk. I have the answers in here. So it's then when it answers, it looks, see how much of it got right or wrong through positive, false, positive. Then it says, you know what, just to make sure everything is cool, I'll do the bottom 2 and I'll test the top, and I'll do the top 1/3 and the bottom 3/3, and I will test on the top. Threefold, they call that, until it comes up with something. All right, good. So the real estate, car, they own property, installment, they own housing, are they renting? Is it free? What kind of a job they have? Fine. Good stuff. Sample, new project. I'm a new project kind of a guy. We're putting in UAE project. Loan risk. Cool. It's semi-cloud object storage because I had this created earlier. So now I have a NoSQL cloud object store. You can put pictures in there. Create. Let me take a look at the chat. The book name, Prediction Machines. Yes, Adam found it. Thank you. It's the one with the 2 eyes. Amazing book. If you like economics, this has an economics twist to it. It's so well written. Just so well written. I go to assets. New asset, yes. Well, there's auto AI. I was going to show you. You can so many things. You can data refinery, pipeline, SPSS modeler, Jupyter notebooks. You can. I'm going to bring in auto AI. Enter a name. Enter a name. Let me find a good name from here. Nagar was here. I love that. Nagar was here. That's what I'm talking about. Associate a machine learning service. Of course, I need a machine learning service. Let's go associate one. Now, since I've been working in here for 20 years, I have them in here. Otherwise, you'll click new service and go get it from the Mall of Dubai. But I have it. Machine learning. LMN. Oh, that's it. It's a good one. It's a good one. I'll take this one. Machine learning. Associate. Reload. Thank you. Create. You see blue, click it. Nice thing. Browse. I can do this. There's no coding. That's what I love about this. You can build a model with 0.0 coding. It was on my desktop. What was it called? The German credit. Okay, we'll get that. Sorry, I have to say it with a German accent. Yeah. How many columns? Come on, you can do this, 21 columns. Is this a time series? 9. So I want my x-axis. You remember those spreadsheet? Everything was a y-axis. That the column that I created as a human, the risk, no risk, that was done by a human, not the machine. The machine gave me the other ones. Is my x-axis. Let's go find that. Risk. See, it knows. Risk, no risk. Binary classification. Let me pick another one. Where was the other one? On rent-free housing. Housing. What do you think housing might be if I picked it? Come on, tell me. If I picked housing, it's not binary, right? Multi-classification. If I picked loan amount, tell me what's it going to be? My year. If I pick the loan amount.
Numerical?
Yeah.
Regression.
Yeah. Regression.
Yeah. Regression. If it wasn't for this, I have to put this in Jupyter notebooks. I have to code this. But back to our regularly scheduled programming, risk. Now, I want to show you some cool things in here. Cool things. The machine says, hey, I'm going to use binary classification. I say, what's about? No risk is there. Recommended accuracy, fine. Do what you must. Oh, there's some algos in here. Decision trees, gradient boost classifier. These are cool. Light gradient boost classifier. Most of these, mesdames and messieurs, is statistics. These are neural networks, LGBM. What it does, it takes this guy, the decision tree. Yes, no, yes, no, 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 yes, no. And, you know, in the decision tree, if you have all yes, 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 it's called a true subset. Yeah, I can't break yes, yes, yes. A decision tree says next, finds one that says yes or no, so I can break it. You know, then the other one, should I stay or should I go? At least I have a chance to have more branches. Gradient boosting says not so fast. I know everything was a no, 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 and you discarded it like it's useless. But not for me. I'm going to give it a little value. Maybe all that no, no, no it has some importance in here. So let's go pick that. Damas. 2 pipelines we can generate 4. I'm going to go with 2. So that means pick 2, just so we can have enough time here. What's going on in here? Good stuff. Good stuff. See, you remember I was telling you about the threefold? It's going to do this chunk, that chunk. And it's going to say, I want you to pick 10% as holdout area. And use that 10% for the, so what's 10% of the 5,000? It's 500. Now, this is a good place for you to do some data cleaning. If social security number, telephone number was here. I think I saw telephone number somewhere here. I want to know people's telephone numbers. Current residence is important. These are probably this is already a cleansed telephone. I'm not going to call anyone. Damas, that was it. Thank you. I have to thank it everything. And I'm happy. Save settings. Run experiment. Look at that. These are muons that are now going through the atomic subparticles. Yeah, that's it. Oh, I get a little woozy when I look at that. Sometimes I do swap view. This one makes it a little bit better. See, let's see when it's going to do the read data. It's 5,000 rows, so you can give it 2 minutes. It's pretty fast. Let me see if there's any chat comes there. Yes. Wesley has a good question. What algorithm does it use to learn? I forget which one. Oh, yeah, we saw the algorithms. Actually, it's going to pick now. It will pick. Let's see which one it picks when it gets to this point. Reading the data. See the 90%, read 10 times, use 10% of it for the test. We know what the answers are on that 10%. So, but the machine is going to close its eyes and says, let me see how good I did on the test. Curious. Who's going to be the selected winner? It's coming. Everyone's XGB classifier. The one with the star means it's a winner, but it's the first one. It's still early in the day. These other guys might become winners. We're doing hyperparameter optimization. It means we're adjusting the weights. Remember, that's the one that changes the slope. Oh, it's not numero uno anymore. Hyperparameter optimization helps, but let's do some feature engineering. Feature engineering is a fancy way of saying, take these 2 columns, multiply them, put them over here, do the sign of that, square this one, maybe installment and housing have something important. That's called feature engineering. Do something with these columns, put them in here. Now, mesdames et messieurs, I'm going to stop. Oh, pipeline 3 is the winner. 0.804. I'm going to stop the experiment. So you can imagine this will go on. It's going to pick another one in here. Maybe pipeline 6 would be the winner. But, it's good. It's all good. Stop it. Pipeline stopped. Let's go take a look at this. Let's say this was it. This was the winner. Did I not? See, if this blue line was going diagonally here, that would be a 50-50 guess. I don't need $1 million machine to tell me it might rain or it might not. If this blue line was hugging all the way to the edge and came down, then that's not good either, because this would be 100% accuracy. That's a deterministic system. Something wrong happened. It's like an overfit. But if this blue line comes in here and makes a a little curve, just a little turn in here and then comes down, maybe that would be 0.98. Now, that's cool. That's what I want. What else? Feature summary. Age. Loan amount. Well, this is probably 99.9%. Loan amount is 75%. Others on the loan. So if you have other people on the loan, the machine says there's a 72% chance you're at risk. You don't say. Credit history, owns the property. See this PCA, that's feature engineering. It did some, for all of them, some mathematics. Isn't that interesting? Confusion metrics. So it was 5,000 rows, right? And we did 10%, right? 500. Where is my calculator? 300. First of all, let's see if it got all of them. Plus 32, plus 74, plus 93. Das sind eine Berliner. So there we go. We have, as they say around where I'm coming from, Alhamdulillah. We got that right. So it says, look, I predicted that 93 out of those were actually at risk. I missed 74 of them. I got the wrong answer. I did better in here. Out of all that 500 rows, when I studied the other 4,500, I got this right. I said there were no risk. I got 300 of them right. I missed on the 32. So our job now is to make this better and better. And you know what else cool thing you can do? Save as. You can save it as a model. And you can use it with AWS and other one, or you can save it as a notebook. Let's do notebook. Create. This is what happened under the hood. While we were clicking away happily and listening to me, this is good stuff. So always make it editable. Instantiating runtime for Nagar. Nagar is giving me good luck. Thank you, sir. And it gets to a good point. Give it 2 minutes. Deux minutes, 3 minutes. Yeah, and make sure you click this. We're into trust business. We gotta trust people, you know. It just makes the kernel, it verifies the Python kernel version 3.7 or whatnot. So look at what this is what happened behind the scenes. What a beautiful notebook. It brought in what's in machine learning, you know, when we said associate, Auto AI, Scikit, XGBoost, open source libraries, connected to the object storage database. I need a database, right? I was holding that training status somewhere. And quickly it says, oh, you got binary, so risk is your x-axis. I'm going to do this, it'll be cool. You can do like 0.2, you know, hold that size 20%, you know, 15. You can have, when your students do this, you can, for example, have each one of them pick something else. See if the confusion metrics will be different. So these are the algorithms that it is thinking about. And it does all sorts of good things. API key, the machine learning. So if you want to connect to Azure, you get the API key from Azure, put it in here, because you can always go file, download as IPYNB file, and put this in your back pocket. You have it in your C: or documents folder. Dankeschön. Now, my dears, I had a lot of fun, and I really don't know what the timing is, but this other section is so good. There's only 3 slides in here. If you can hang with me, we'll go through this. Are machines going to replace me? This, all right. So prediction relies on data. That means humans have 2 advantages over machines. We know things that machines don't yet, common sense. We are better at deciding what there isn't much data. This morning, when I woke up this morning, my feet hadn't even touched the floor. I hadn't even had my sip of water. I knew it was going to be a great day. Good luck to the machine making that prediction. Humans have three types of data machines don't. Yeah, with a sense of smell, touch, feel. I got a hunch. Good luck to the machine to come up with that. We are the final arbitrators. You know, the machine will tell me, Armen, it's going to rain tomorrow between 1 and 2 p.m. What a perfect prediction. Take your umbrella. You don't tell me to take my umbrella. I don't take umbrellas. I don't like umbrellas. I have this special hat that I wear when it's raining. You don't tell me to take my umbrella. We decide these things. Privacy concerns restrict the data available to machines. As long as enough people keep their sexual activity, financial situations, mental health status, and repugnant thoughts to themselves, the AI will have insufficient data to predict. But ladies and gentlemen, the winner of the AI race is not the country or the entity with maximum information on their people. No. Or the company that came up with the master algorithm. No. The winner of the AI race is the entity, the scientist, the university, that can do maximum prediction with minimum data. That is what I'm looking for. That's me. I didn't have a whole lot of data to find out it's going to be a great day today. I had just woken up 3 seconds earlier. That's where I want the machine to go towards. And so the foundational AI, building a common sense as we moved towards artificial general intelligence, is ushering in this new era of AI. And again, I stole that shamelessly from this book. Humans, they excel at morals, imagination, and compassion, judgment. Yep. Common sense. It's coming. This common sense is going to end up over here. Machines excel at pattern identifications. You know what machines excel at? If then else scenarios. I kind of get woozy after a while. You know, if I leave here at 4 o'clock, I can probably pick up my sister by 4:15. And that should get me to my dad's house by 5:40. I think there's going to be traffic but not the AI system. The AI system goes through if then else traffic. There's going to be a weather coming and the construction's happening over there. All these quickly. It gives me a nice reckoning of what's the best decision, the path to go. Oh, yes, good stuff. I have a great story for you. Great story. You're going to love this. There are 3 major AI calipers. Narrow intelligence. That's where we are now. The best of Tesla, Google, all their driving cars. That's where it can do one thing and one thing good. You know, my phone is really good and really doing one thing. Mesdames et messieurs, can I tell you, I experienced this. I have experienced this. This is not, we're not there yet. This is 10 years to go before we get here. But a slight version of it. It was 2018 before the COVID came. And used to travel and had my Hilton rooms at the top corner back then. And I was invited to go to Carnegie Mellon University, CMU, the robotics department. I'm like, where am I to go there? But, you know, I know the tools. I'm 1 page ahead of them. So that's all you need to do is be 1 page ahead, get to talk. So I went there and I was good. This is not a true story. I was greeted by a robot at the concierge when you walked into walked into the robots division, the building, and I was good. So it wasn't a humanoid. No. It just had a lens here, no arms or anything, a big screen in here that gave me information. I walked in, the legs was just a pod with a tractor, kind of a. So I went in, I'm like, oh, what's going on? Hello. Hi, Armen, welcome. So it had my bio, facial recognition. I was told if I had got there, asked I was like, sure, that's good. Follow the thing is getting greener as it gets closer. I think it was getting greener. I'm colorblind, red and green. They gotta pick a different color. Color was changing. It's going. We went by the elevator, and one of the AI engineers chair the machine. Just standing like he was waiting for me to do this. Kick the chair in front of the machine. The machine, laser, LIDAR, no big deal. Well, LIDAR is expensive. It stops. I stopped too. I'm looking at her. I don't know what to make of this. The machine goes around the chair, continues going. I didn't touch the chair. I followed the machine, went around the chair. We got to John's office. John asked the machine 2 questions. Hard for a human to answer, let alone a machine. Oh, it answered those 2 questions. What happened at the elevator? Why were you late? That's awareness. It's becoming aware of its environment. That's it. It's experience. It's not just training. This, ladies and gentlemen, I won't be here to see this, artificial superintelligence. Let me tell you an example of an ASI. Today, I might ask Watson, can you tell me about black holes? Well, Armen, I'm sorry, I don't know about black holes. Perhaps you can teach me. Eat this PDF. It's the PDF, now it knows about black holes. During the ASI there, it's hard to imagine they won't know anything about the black holes, but the response might be, I'm sorry, Armen, I know that I don't know about black holes. Can you teach me? Self-awareness. Armen, do humans like me? Am I pretty? This is when they would get together, come into the city. There is no automobiles. There is no asphalt. There is no parking lot. There is no car insurance. They come, they take us around. They clean the streets, they police, they come into the house, they cook food, and they watch over it. At the end, at the night, they go to their own town. They elect somebody amongst their own AI systems, and they have a leader, and they stay there. And then next day, they come back and service the humans. 2040, will I see this? Yeah, I think I'll see this. I'll probably bug out somewhere right out here. I won't see this one. Whew, thank goodness.